This is a continuation of the video notes for 9.3, Getting Schooled. So I, by accident, shut down my recorder. So here we go, recording the last half of the notes. My apologies. So we have our equation for the income for women with bachelor's degrees or higher. And we have the correlation coefficient, and I didn't sketch the graph. I just did a screenshot and then copied it here, but go ahead and take a moment to sketch that graph into your notes. If you want to pause the video, you're welcome to do so. All right, let's go ahead and move on to number 8. In number 8, it says, now that you've analyzed the results for women, compare the results for men and women with at least a bachelor's degree over the period from 2000 to 2011. So what I'm going to do is I'm going to transfer my two lines of best fit, my regression lines for men and women. Here's the one for men. So men are have the line of best fit, y equals negative 589. I'm just going to round up because it's actually 588.46. I'll just round up to the whole dollar. X plus 69,978. And women, theirs is y equals negative 82x plus 43,357. And I'm going to write two comparison statements. The first one I'm going to talk about is for the men. So the men, they definitely start at a higher income, and they decrease more each year. So do you see that? They start at 69,000, which is considerably higher than the women, but they also are their income is going down a lot more, about $500 more each year. So that's my first comparison statement. My second comparison statement has to do with the women's equation. I said women start at a lower income and decrease less each year. So they're seeing less of a hit yearly, even though they started, I would say about 27,000 lower than men, even having a bachelor's degree. So I do want you to recall that in 9.2, right, in lesson 9.2, when we were comparing making more money, we were comparing the median income for men and women in the whole United States. I don't know if you remember the starting salary for men. All men in the United States was $37,000. So with a bachelor's degree, there's a huge jump. It's goes from 37,000 to almost 70,000. For the median income for women in the whole United States, it was 18,000. So if they have a bachelor's degree now, it jumps to 43,000, which is considerable. All right, let's go ahead and start our takeaways. Our takeaways talk about ways that data can be used to make questionable claims. One way it could be used to make questionable claims is by focusing on one aspect while ignoring all others. For example, we did that in lesson 9.2. We just focused on straight up median income, not paying attention to other factors that might be affecting the income, such as just having a high school degree or having a bachelor's degree or higher, or maybe not even going into the workforce. That primarily would affect women if they were stay-at-home moms rather than having a job in the workforce. Another way that data can be used to make questionable claims is by claiming that one variable cause and effect when the correlation coefficient is strong. And we actually saw that in lesson 9.2 when Shaniqua was having her study party and they just happened to eat lots of pizza. Now, she gathered data about how many pizza slices they ate, but is that Really, the reason they had improved math scores, their correlation coefficient was +1. So that indicated a strong positive correlation, but you also have to use common sense, right? So be skeptical. Even if we have a strong correlation coefficient, it does not necessarily mean that one variable is cause and effect in the other. Another way that data can be used to make questionable claims is extending your models beyond the available data. So in lesson 9.2, we actually did a few predictions, right? We did predictions for the median income of men and women in 2015. Now, we have to be careful when we do things like that, because who knows what's going to happen in the years where we don't have data, right? Our data initially went to 2005, and then we had 6 more years added, so our data went to 2011. But both times we did predictions, we did estimates, we estimated in 2015. So initially that was 10 years past our data, and then it was 4 years past our data. So be really careful when you extend your model past your available data. A good example of this is, let's say people were analyzing data like 100 years ago. Could they really predict where we are today, not having information about things today? Probably not, right? So you want to stay within a reasonable distance from your data. Don't go too far away from what you know. All right, one last one. Ways that data can be used to make questionable claims is disregarding possible other factors that represent the relationship between the variables. And that goes back to the first one, focusing on one aspect. I talked about in 9.2, all we did was median income for men and women for the whole United States, and we didn't take into account any other factors. So there are a lot of other factors that could be influencing the relationship between the variables. Now we're going to do our last two parts of our takeaways. This next part has us reminds us how to find a slope between 2 points. So the slope is m, right? It's the rise over run. It is y2 minus y1 divided by x2 minus x1. And you can see in this little graph that I drew, let's say I have these 2 points. Let me zoom in a little bit more. So I have this point over here with the ordered pair x1, y1, and this point over here with the ordered pair x2, y2. And if I wanted to find this slope here, I would need to find this rise, right? That's this value up here, and then this run, this value up here. And to find the rise, you want to find your vertical difference between y values. To find your run, you want to find your horizontal distance between x values. So there's a reminder for you how to do that. We practiced this skill at the beginning of 9.2, where we hand drew in our lines of best fit and wrote the equations for them, but here's a good reminder for you how to do that. All right, let's turn our page, and we're going to give a little bit information on how to find a y-intercept given a slope and a point. So let's just give you an arbitrary slope and point. So our slope will be 50, and our point will be 1, 450. And this is how you find the y-intercept and ultimately the line that has that slope and goes through that point. The very first thing that you want to do is you want to write your equation, right? Y equals mx plus b. And we're going to replace a few things with the information that we're given. We're going to replace the y with the y value that we're given. We're going to replace the m with the m value that we're given. And then we're going to replace the x with the x value that we're given. The only thing that remains a variable is b, which is the y-intercept, right? So that's okay, it's still a variable. It's okay that we don't know it. We're going to solve for it in a moment. Our second step is to solve for b. And in this situation, it's pretty easy to solve for b. On the right side, we have 50 times 1 We end up subtracting that from both sides. We end up with b equals 400. Finally, if we needed to write an equation for the line that went through that point with that slope, we would put it together as y equals 50x plus 400. In this lesson, we compared two sets of data to draw conclusions about men's and women's incomes. We interpreted the meaning of the correlation coefficients, the slope of the regression line, and intercepts of the regression line. Remember, regression line, whenever it says that, is just line of best fit. We use the data to make claims and challenge the claims of others. Okay, so that was our lesson. Finished up our lesson 9.3, Getting Schooled. If you have not yet recorded Desmos line of best fit formula, I would strongly recommend it. It is y1 tilde mx1 plus b, where the ones refer to table 1. So make sure you don't skip writing the ones, because it needs to know where to get the data, which table to reference. I wish you best of luck on your practice, and I hope that this video helped. Thank you.